HTML is the hypertext markup language. HTML is all about identifying commonly used structural elements like paragraphs, headings, lists, links, and more. Computers understand the structure of a document through this type of markup. This will help with searching documents, search engine optimization, and making documents accessible to those with disabilities. Let's go over those key points again. First, HTML is all about the page structure. Notice we haven't mentioned something blue or having a different font. That's not part of HTML. That's CSS, or cascading style sheets. Your web browser has a certain unstyled look that it assigns to raw HTML, but HTML has no inherent look of its own. Second, HTML is all about elements. There's an element for every need, it seems like. There are over 100 elements you can work with. Finally, use the right element for the right structure. If you're representing a paragraph, use a paragraph element. If you're using a quote, use a quote element. Let's quickly go through how HTML is formed. Here is an example of a link. This is made up of opening and closing tags, in this case, the A tag. A stands for anchor, and it's used in creating links. When we talk about the two tags together, this refers to the element. You'll notice in the opening tag, we have a few modifiers available to us called attributes. The href attribute stands for hypertext reference. In other words, where do we want this link to go? The target attribute addresses where we'd like this link to open. In this case, we want it to open it in a new window or tab in the web browser, rather than the default behavior of the same window or tab. The words in between the opening and closing tags are the text affected by the tags. In this case, this text will function on the page as a link. How will that look? Well, that depends on what the CSS says. By default, links are blue and underlined according to our browser's style sheet, but it's likely your website developers have overridden that default behavior and made it look somewhat different. Finally, you can have elements nested inside of elements. Here, I've used the paragraph element, composed of these P tags, to wrap around our text. Notice that elements are nested inside of each other like wooden dolls. The tag is completely contained within the paragraph. That's the proper way to work with your HTML tags. You can't close the paragraph before all of the elements inside are closed. HTML is an excellent skill to master, as many content creators wind up encountering a little HTML here and there. If you're wondering if code might be something fun, HTML is an excellent place to start exploring. CSS stands for cascading style sheets. If it looks pretty or if it arranges elements on a web page, CSS is probably behind it in some way. Style sheets as a concept have existed in print and software for a long time. Microsoft Word, for example, styles your documents in a certain way, with certain fonts, margins, and colors. The same is true with CSS. Here, you'll declare that you want your document to use specific fonts, colors, spacing, and layouts, and the web page should act accordingly. HTML, therefore, simply outlines the structure of the web page. CSS gives it the overall look. So where does that look of unstyled HTML come from? Those giant Times New Roman headers, the blue underlined links, these come from a style sheet as well, one that's associated with your web browser. HTML itself has no look. This is a super important concept to understand, one that's commonly forgotten or confused by many professional web developers. CSS is often contained in its own separate document, which is linked to your HTML page. CSS is formatted in the following way. Here we state that all paragraphs in our HTML document should have a text color of FF0000 or red. The color is written as hexadecimal code, specifying the shade of red. What if we want to have just one paragraph as the red paragraph, maybe a warning of some kind? We can use a CSS class to make that happen. The cascading part of CSS is a little more difficult to understand. Indeed, some developers spend years understanding how it works. For now, there are styles that are broad and apply to many elements on your page, but they can be overridden by different and more specific styles. Seems simple enough, and perhaps that's the biggest problem with CSS. It's consistently underrated in language difficulty because the syntax is straightforward. However, the CSS language grows yearly with new styling properties and values, new ways to lay out web pages and animate elements, and new ways to manage styles for multiple devices. Don't be deceived by the simple syntax. CSS is a complex language which will take time to master, just like any other language. If you're a graphic designer or if you have design inclinations, CSS will be the most fun part of web development for you. You'll get to write a little CSS in the coming chapter. Imagine the web as a rock band. HTML would be like the bass and drums, creating a foundation for all of the other musicians in the band. CSS would be the rhythm guitar, establishing a bass chord structure for the music and filling in holes where the lead singer wasn't singing. JavaScript would be that lead singer. Without JavaScript, we could have functional web pages, but they'd be a little boring. JavaScript is the special sauce that makes the web page interactive. Most of those items that change online are driven by JavaScript. Panels that expand and contract, intricate animations, drop-downs and fade-outs, error checking, and infinite scrolling. All of these things have some type of JavaScript behind them. JavaScript is a scripting language invented in the mid-1990s by Netscape, the company behind an early web browser. JavaScript and Java have nothing to do with each other. Java is used more for applications, particularly in Android-based applications and in big data. JavaScript was born on the web and continues to live there. Like CSS, JavaScript is usually contained in its own documents and linked to the HTML page where it will execute. Since JavaScript is a programming language, it includes many of the same elements you find with other languages. For example, it includes variables, control structures like if-else and loops, data structures like arrays, and so forth. Frequently, JavaScript executes in response to events on the web page. For example, when I click this button, I launch a modal window or open an accordion panel. In general, JavaScript is closely tied to your HTML. Here, a prompt box opens when a web page loads. It asks for your name and then returns a greeting on the web page inside of the paragraph with the ID of Hello World. In this case, the JavaScript is taking words typed into a window and creating text to write to a web page in response. HTML and CSS don't do this, which is why JavaScript is complementary to our technical stack. If you learn to program for the web, you will shortly encounter frameworks. In this context, a framework is some pre-written code that you may use to create all or part of your website or web application. Frameworks often consist of CSS and JavaScript. Some rely on your HTML being crafted in a specific way for the framework to function correctly. A commonly used framework that's beginner-friendly is Bootstrap, found at getbootstrap.com. Originally released in 2011, Bootstrap originally functioned as a fast and easy way to create responsive websites. With Bootstrap, you may create website layouts, buttons, color and font schemes, and functionality like drop-downs, hamburger buttons, accordions, and modal windows. More recently, JavaScript frameworks have become wildly popular. Facebook's React, open source Vue, and Google's Angular are the three most encountered frameworks for front-end development. Frameworks in general are often used for two major reasons in programming. The reason that most people want to discuss is that a framework significantly speeds up development time for building websites and web applications. A significant portion of the code is already written. Some parts of the framework may be designed for quick customization. Often that's things like colors, fonts, layout options, and so forth. Developers may also write additions to the framework to make their customized solution for a client. Frameworks are maintained by a team of people and are often free, so the code will be updated on a regular basis. Think of a framework in this context as an unfinished furniture kit. You may need to assemble unfinished furniture or sand it and paint it. However, someone has already conceptualized the item you'll build with the kit. Someone has given you all of the assembly hardware required plus the instructions to put it together. You're adding your own special touches and considerations to make the perfect custom piece of furniture that you want without paying a custom price. The other reason developers love frameworks has a darker side. Frameworks may also serve as a crutch in web development. Rather than truly learning HTML, CSS, and JavaScript and using a framework for a productivity boost, developers instead use a framework as a crutch to build something they're otherwise incapable of building on their own. Unfortunately, these products are all over the web. Applications that are poorly constructed, slow to load, and full of security and usability problems. Using frameworks isn't inherently bad, but using it as a substitute for a real background in web work should be avoided. To that end, I recommend learning HTML, CSS, and JavaScript as their own formats first, and then add frameworks to help boost your productivity later in your education.